Thank you so much. Yes, welcome everyone to Algebra, Not Algebra. I think that title is self-explanatory. We've probably all said that at some point in our lives or know someone who has said that. So I'm glad that you're here. We're a small but mighty group. I am Lindsay Poost. If you do not know me, I work at Atlas with Patsy, and I am the Numeracy and Special Projects Coordinator. And I have a special love for math. And I'm excited to get to do math with you today. So the agenda we have, we're going to do a warm up in the chat in just a moment. We're going to do some guided play where you're going to have a chance to unmute and share some reasoning about some prompts I have on the screen. And I have enabled annotations so that you can share your thinking by writing on the screen as well if you would like to. And then we'll also do kind of an individual Jamboard. So if Jamboards are not your favorite thing or they're not as comfortable, you'll have kind of a low risk way to engage with that on your own before we collaborate in one or more small groups where you will get to talk to each other and collaborate together on a Jamboard with some algebra prompts. And then I'm going to share some additional resources with you before we wrap up, and then we will call it a day. So the warm-up, pick two. All right, this is like Panera, right? Pick two. So when I think of algebra, I think of blank, or as a teacher, algebra is or was to me or for me. As a student, algebra is or was to me. So pick two of those and write some sentences, fill in the blank. Let's start this way by sharing our views of the word or what we think of as algebra. And I'll give you some time to write. I know you need time to type. Responses are starting to come in. You still have some time. And I am going to read some of these out loud. Keep them coming, but I am going to read some of these out loud in case anyone is watching the recording and the chat's not there. So when I think of algebra, I think of X's and Y's. As a student, algebra was about knowing the right procedures and when to apply them. When I think of algebra, I think of solving for unknowns and puzzles, numbers and variables, PEMDAS. As a student, algebra was not my favorite subject. When I think of algebra, I think of learners freaking out with the word. As a student, algebra was easy for me. As a teacher, algebra is hard for me to explain. When I think of algebra, I think of equations and process. When I think of algebra now, I like to look for clues for solving a puzzle. What happened? How do we undo things to solve the mystery? Okay, so there's a lot in there, a lot of similarities. And there's another comment that just came in, like, as a teacher, algebra is difficult to teach. And so this idea of maybe it's easy for us or was easy for us, but then teaching it is a different endeavor. And some of us, it was easy, some was hard, it was like puzzles for some of us, and some were like, we don't like it, right? And so I think it's just important to kind of recognize where we're coming from when we're thinking about algebra and all that entails. I mean, that's a huge word that encompasses a lot, but because I think our perception, whether it's easy or whether it's difficult, can be projected onto students. And so just kind of being aware of that, I think, is a good thing. As a student, algebra was challenging, but could be fun when you got it right. Another comment, as student algebra was easy for me, but as a teacher, I have a deeper understanding. Yes, it was not until I started teaching that I started actually understanding math. Otherwise, I just memorized a bunch of stuff. So thank you for sharing all of that in the chat. So the objectives for today, the main thing that it's not, like we're not going to cover an extensive amount of algebra, but we are going to experience a routine, and you may have experienced this before. So maybe it's the second or third time. That's okay. We're going to engage with math. So you're going to still get to do that and engage with math content. And also reason about mathy relationships, specifically about equivalent equivalent statements and unknowns with your colleagues, with all of us together. And then hopefully my hope is that you will leave inspired to adapt this in some way, or maybe it sparks a completely different thought, but this conversation here today sparked it for you, of something that you want to do with your students to help bring out this thinking and this reasoning. So we're going to jump into some prompts that we're going to do together. And the routine we're going to work with today is always, sometimes, or never. How many people in the chat, you can put yes or no, how many people have worked with always, sometimes, or never, or done it with your students, or done it yourself? You can put yes with students, no with students, anything in the chat. Yeah, so yes for some, no for others. So again, even if this is a familiar routine, I still think that the conversations we're going to have, that's the main focus. So if you have never done it before, always, sometimes, never, it's an instructional routine where students have to make an argument and justify their reasoning for why a statement is either always true, sometimes true, or never true. You will get the PDF of the slides after today. And so I have some additional resources linked here that I'm not going to open now, but just some more examples of like, what are more statements we could work with, or explanations of the routine. So you will get this PDF of the slides. So you will have those links to look at on your own time. So I'm going to start with just always or never true. Okay, so it's like true or false, right? So I want you to think about this statement, this math sentence, and I want you to think, is it always or never true? And how do you know? Like, how would you explain your reasoning? So I'll give you a moment to think. You don't have to put it in the chat, but think on your own for like 60 seconds. Always or never, and how do I know? Okay. Second question. Is there anybody feeling brave, wanting to share your thinking with us? You can unmute and share. You have this white space on this slide. I've enabled annotations. So if you want to write on the screen, you can. Here's the problem again in some handwriting. If you go up to view options, I think it's, yeah, if you go up to view options and then select annotate, then you should have some options for selecting a pen or something. So you don't have to write on the screen, but if that would help you explain and you want to unmute and share, that is an option available to you. So does anybody want to unmute? You can either raise your hand or put me in the chat or something and share. How do you know, is it always or never true?
I can volunteer.
Go for it.
May as well. So I said always. Sorry, I'm with my daughter. Daycare closed unexpectedly.
I get it.
She wants to talk about math too.
I love it.
I would say always, because even if you rearrange the numbers on either side of the equal sign, or even if you switch the groups of numbers onto either side of the equal sign, it's still true when you do the math and change around the numbers. So that
Okay,
was
so
my thinking.
I love that. And I have a follow-up question. When you say rearrange the numbers, what did you?
So on the left side, if I was to do 2 + 7 + 3, or 7 + 3 + 2, and then on the right side, if I was to do 2 + 10, it doesn't matter how they're arranged, they still equal 12. And then the same, if I put the 10 + 2 on the left side and the 3 + 2 + 7 on the right side, they still equal 12 when I add them together. So no matter how I rearrange the equation here, it's still always true.
Awesome. Thank you for sharing.
Yeah, not a problem.
Anybody else want to share? Did anybody have a different way that you want to share? You can say no. I'm just leaving it open. Rebecca, you agree with Justine? Awesome. Okay, so I love that. I did not see that as like, if I rearrange everything, no matter what, I get 12. And I could even put the expressions on different sides of the equation and get 12, right? On each side. So one thing that I did, I rearranged the numbers, but in a different way, which I think, a side note, these kinds of prompts can lend themselves to really rich discussion because everybody thinks about things differently, right? So I was like, oh, well, if I group the 7 and 3 together, I get 10. And then I still have to add the 2. And so now I have 10 + 2 = 10 + 2, which in my mind, I'm like, oh, I can really see that's the same, right? And then I just stopped there because I was like, 10 + 2 is the same as 10 + 2. But that's just one way of thinking about it. And so there's a couple different ways you could explain, like, how do I know is always true? All right, next one. Think about this math sentence. Always true or never true? And again, how do you know? And these ones that we're doing at the beginning, they're just kind of warming us up. So I'll give you a moment to think about it. And then the next question is going to be, will I unmute and share? If anybody would like to share, is it always or never true? And then how you were thinking about it, how you know, how you would justify your answer, feel free to unmute. Go ahead, Rebecca. And you can write on the screen if you would like as well.
Okay, so these are that tricky one where we want to start with that 4 - 4, but if I picture, oops, I didn't annotate. It says I click on annotate and it's not doing anything. Okay, so I'll just talk it through then.
Oh, shoot, okay. I can try to represent your thinking. Try.
Oh, it thought it did a second ago. Okay, I'm not sure. If you picture a number line on the left-hand side and you've got 14, start at the number 14, and then I'm going to move 8 steps to the left to show subtraction of 8. And that's where I land, would be at 6. And then if I want to compare that to the other one, I could start at 14 and think about moving 4 steps to the left, and then another 4 steps to the left, and I would still land on the same spot.
Okay. Natalie says she thought of a number line as well. So in both instances, you are landing at 6. Just looking at the time. Okay, I love that you brought in a visual, because that's another way that we can use to describe our reasoning. Did someone else want to jump in?
Nope, that was Nora pushing the button. I'm sorry.
She wants to jump in. I love it.
It's doing two things at once. She's very fascinated by this.
I love
She's
it. I love it.
gifted. We love it.
Yes. So you could draw another visual. Again, this is just how my brain thought of it. Okay, you have 14. If I take off 8, I'm left with 6, which is the same as taking off 2 chunks of 4, which if I even add 4 and 4, I'm getting 8. And I can also just take away 4 and have 10 left, take away 4 and have 6 left. So I could I could draw a picture. So the purpose of these warm-up prompts that we're doing right now are to kind of show, like, what are the different ways that I could explain my thinking, because we will be dealing with unknowns in just a moment. So I can use words, I can speak, I can use words like writing, I can speak, I can draw pictures, I can use number line, which is another picture, I guess. And so this is our next one. 2 times 3 equals 2 times 4, always or never true, and how do you know? And when you want to share your thinking, you can either let me know in the chat, or you can unmute and share how you would explain your answer. Go ahead, Natalie.
All right. So for this question, I like to think about objects. So I'm thinking of Jolly Ranchers. I have 2 friends, and if I give each friend 3 Jolly Ranchers, I've given out 6. And if I give each friend 4 Jolly Ranchers, I've given out 8. So I would say this is never true.
Because is there any other option besides what you just described?
Nope.
No, right? Exactly. And I love that you used a concrete example. I stayed very, not theoretical, but kind of, just in the sense of 2 3s. Any 2 3s, right, is never the same as 2 4s. And so we might have, we might want to give an example like you just did to explain your reasoning. Like I said earlier, like using words, right? There's so many different ways that we can help our students explain their thinking. It doesn't have to just look one way. And yes, I agree with you, Rebecca. It's a great opportunity for concrete examples. So we are going to do one more warm up. Let's add sometimes true now back into the mix. So this is an always, sometimes, never true routine. We were only using 2 of them. So is this always, sometimes, or never true? 2 times a number is the same as 1 times a number. How do you know your answer is correct? And I see some sometimes coming in. Sean, would you be willing to unmute? You can tell me no, you do not have to, but would you be willing to unmute and share?
Sure. So my thought process is that I can provide an example of both it is with 0, 2 times 0 and 1 times 0 are both 0. And then I can provide an example where it's not. 2 times 2 is 4 and 2 times 1 is 2.
Okay, I love that. You have an example and you have a counterexample of when it's not true. And so therefore it has to sometimes be true. That's awesome. And I too said the same thing, like 2 of a number is always different than 1 of a number unless it's 0, right? And then you get the same answer. And so sometimes it's true. So what we're going to do today is we're going to really focus on unknowns and the equivalent statements. Are they equivalent? Which really starts to highlight and emphasize the discussion about what the equal sign means. And I think that is something, that is a concept that we can take for granted sometimes, like the equal sign is right there. So everything on this side is the same as everything on this side. And we know how to group the sides together, that this whole thing we're saying is equal to this whole thing, like the 7 plus 2 plus 3, and then the 10 plus 2. Nope, that didn't make sense. What did I have? Anyways, those two that we looked at earlier, we know that they're talking about all of them together, and then they are equivalent. Sometimes though, when we write stuff on the board, I have been guilty of this. We'll like write like 7 plus 3 equals 10. Okay, now add the 2 on, and then that equals 12, right? But this is not a true statement, because this is 10 and this is 12. So now we're saying 10 equals 12 in the way we wrote it, right? So kind of sometimes we know it's not equivalent, but we'll just keep adding on to a previously completed statement instead of going to another line to then make 2 different equivalent statements, right? Yes, it's super easy to do, and I've been so guilty of that multiple times until someone pointed that out. Like it's kind of like a shorthand, but it's actually incorrect, and it doesn't help our students understand what this really means. And so that's something I think that as teachers we can be aware of, and also knowing that that equal sign and the meaning of that equal sign, it's not always apparent to students. And so that is going to come out in these conversations where we can really kind of keep a teacher's ear open and eyes open for how might we encourage that deeper understanding in our students of what that equal sign means. So I'm gonna give you 2 prompts in just a moment. We are going to put a link in the chat for you to open up a Jamboard. This one is individual. There are only 2 questions. So these are the 2 questions you're gonna interact with. So it will prompt you to make a copy. And I'm doing it this way because this is going to give you a chance to just try this on your own, and maybe not everyone's comfortable with Jamboard, maybe everybody is, but then you don't have to worry about like doing this in front of anybody. So this first prompt I want you to look at: 0 times a number equals 0 divided by a number. I put the same thing just in symbol form below, but it's the same statement. And then you're going to just choose, is it A, B, or C? So I guess this is multiple choice, not matching. A, B, or C. You're going to choose the reason. So I'm supplying the reason for you. Up here where the arrow is, you can just arrow over and you'll get to the second prompt. And again, the same statement, one on top of the other, just different representations. And how would I, what matches this situation? Is it A, B, or C? And so you can just think about it to yourself, or if you wanted to use these tools over here, maybe you want to click on the pen and just circle one. Undo is what I was looking for, or circle one, or whatever. You can mark it any way you want, or you can leave it blank, but just an opportunity to kind of practice navigating in Jamboard in your own copy. So we will drop the link, and again, this will be done individually, so you'll stay right here, and I'll give you a few minutes to look at those prompts. And yeah, Patsy just put the link in the chat. If you have trouble opening it and you can't, I have another way that I can give you if it doesn't work. So just let me know. This is not a race. When you do complete it, so that I'm not sitting here and you're just waiting for, you're all waiting for me to move on, just put in the chat, like, I'm done once you finish, okay? Okay, so let me. again, if it won't open for you, let me know. I have a workaround. If you're finding mistakes, I apologize. Let me know. And I will, yeah, if you are done, you can put it in the chat. Again, I'm not trying to rush you. I just don't want everyone to sit if you're all done. Some people are finishing up. If you are done, I agree, Rebecca. I'm also biased because I purposely made these options, but I agree that there is a lot of conversation available on the table with just these two prompts. Think about like, what would I want to talk about with my students? So if you're waiting for us, then think about what kinds of conversations could I have with students based on this exercise? And we'll get together in just a moment. Okay, so I'm seeing several people are done, and if you're not done, I apologize. Let's talk about this. What did you notice? You can either type in the chat or you can unmute and share. Like when you were going through this, what did you notice as you were completing this exercise? Or what questions did you have? Rebecca in the chat says, great question for students. What does two negative numbers make a positive mean? That would foster a really good discussion because it's something we say and it's something we hear students say. Anything else as you were completing this? Thoughts you had? Questions you had? Conversations you might have with students? I will say, and if you're still typing, please keep doing that. I tried to make all of three options on each page. After the because, I tried to make either a statement that students say or make it true, because I didn't want it to be so blatantly false that students would be able to use process of elimination. What you would really have to do is say, like, what actually matches this situation, right? So like in this first one, okay, this is never true because multiplication and division are opposites. Well, we can say multiplication and division are inverses, they're opposites, but like, does that match the situation and like why this would always sometimes or never be true? And so I tried to make statements that would be familiar to students so that it kind of forced more, a little bit deeper thinking of what reasoning actually matches the situation in front of me. For this one over here, this is always true because the X is the same number in both expressions. Well, yeah, we want students to be able to realize, like, if X is on one side of the equation, in that same equation, if there's an X on the other side, it's going to represent the same number. Like, it's not going to be two different values within one equation. And so that part is true, that X is the same number in both expressions, but does that make the statement always true, right? So I tried to craft them in that way, that there might be some truths, like half truths kind of sprinkled throughout the options, so that it would potentially force some deeper reflection. So yes, it is A for the first one. For those who are like, I want the answer. It is A, like, it's always true, right? They're both always going to be 0. And for the second one, it is the last one, C. And you might have a different way of explaining it. You may have a better, more clear way of explaining it, and that's totally fine. This was just something, you know, a way that I thought of to explain why one would be never true and one would be always true. So oh my goodness, see, I knew I was going to make mistakes. Sean, can you say more?
For the first one, if you had 0, 0 times 0 is 0, but 0 divided by 0 is undefined.
Yes.
So it's sometimes true.
You're right. Oh my goodness, look at that. Okay, I knew I was going to make a mistake and I knew someone was going to catch it. That's great. This is why
well, I get to teach undefined like every day, so
oh my
gosh.
gosh.
My brain.
No, I love it. Okay, so it is B. See, it is B. Anybody else miss that? I mean, you don't have to say if you did, but I'm just curious because I totally did. Did someone want to jump in? Anybody else? I thought I saw a hand, but maybe I didn't. Okay, and this is why we do math together, because we can catch things that others don't. So, we are going to move into a time of breakout groups. And so I think we'll have 2 different groups, and you're going to get to work on more examples, lots of examples. We're going to have a good like half hour in breakout groups. So if that scares you, it's okay that it's scary. Like, sit with the anxiety. I have anxiety and I'm learning, like, I just need to sit with it sometimes. So I get it if you're like, run breakout groups, but please don't. Your ideas and contributions are really valuable. So a couple notes before we get to the breakout groups. If you see a question mark and or a box in the examples I'm giving, if it's within the same equation, assume they are the same value, just like X. If X is on one side of the equation, it has to be the same value on the other side of the equation as well. So for what do I mean by that? For one of the screens, you're going to see a lot of statements that have boxes. Within one statement, assume that this box is like an X. Okay, I just didn't use an X because sometimes our students aren't always ready for that. So, but assume it's an X, so that means it has to be the same value over here. So when you're talking in your groups, like, is this statement sometimes, always, never true? What I put in here has to be the same as what I put in there. And same with, one second here. And no worries, Catherine, you're going to get to do a lot of this breakout group. Let's see. It's just being super slow. I'm so sorry. But same if you see a question mark, it will be on here. So if you put in any number here, you have to put in the same number on this side of the equation. So so assume that they function like x's. I just didn't want to only use letters because sometimes students aren't ready for that. But you will, when you get the links, and we haven't given them to you yet, but when you do get the links, you will notice that there are equations, math statements to look at for levels A, B, C, D, and E. And you don't have to get to all of them, but you have options, okay? So, and I also put the standards that I was working with here, if you care. If you don't want to look at that, that's fine. But level A, if I arrow over, then I'll see these statements and I can drag and drop them wherever I think they may go. Down at the bottom are potential prompts, sentence frames, to help explain your reasoning, right? It's always, sometimes never true, because an example is, a counter example is, and then just a question, like maybe you want to draw a picture, or you can use the pen icon over here, or maybe you want to draw a graph, or you want to make a table or something to kind of show your reasoning. You can do that as well, or you can share it verbally. As you keep arrowing over, you will see different statements, level B standards, level C standards. Now you see X's. Now you're getting to see some variables, X's and Y's. Level D, again, letters, but different kinds of formulas or different kinds of equations, because you're dealing with different relationships at level D. And then level E, I created some relationships. I also created some if C equals this, then R equals that, because for level E, especially if you're working with adult diploma students, there is a standard that asks you to demonstrate that you know how to solve for a variable within an equation. And so there are some examples here, like, did I solve for the variable correctly? Is that always going to be true the way I did it? So those are the options. So if I go back to the instructions, what I'm asking you to do is to navigate as your group. You're going to navigate to a page with math statements. You don't have to start at level A, go where you want to as a group. One person, choose one of those statements and make a decision. I want to do this one. I think it's always true. I'm going to drag it to always true. And then I'm going to explain to you why. Group mates, ask questions, probe, like, make it a conversation. And then after one person chooses a statement and kind of explains, then another person can choose a statement and then explain it and share why, and group mates can answer questions, so, or ask questions. And then if you would like to, because I know maybe not everybody has access to Jamboard, one person can share their screen in the breakout rooms. So we will be going to each breakout room after we open the rooms and make sure that you have your link and that everything's set up, so you're not sitting there for half an hour just like with questions. So we'll make sure everybody gets set up, but that is an option that you can share your screen if you would like to. Last thing, you will, this is what we're going to talk about when we come back. So again, you're going to have extended time. You're going to have 30 minutes in your breakout groups. I'm going to pop around. If you see me in there, and it's not like me helping you get set up or whatever, you can pretend I'm not there. Okay, I just kind of want to hear different conversations. But then we're going to talk about like what ideas surfaced in your group. What are ways that you could adapt this? Because this, like, Jamboard isn't going to work with every setting, right? Like, there are corrections that are represented here. That's, I recognize names. And so it's like, well, Jamboard isn't going to work. Well, how else could we do it? And then maybe questions that you have. So just think, like, those are the kinds of things we'll report out on when we come back. All right. We're going to drop links to the Jamboards in the chat. If you are in Zoom group 1, you will be Jamboard 1. If you are in Zoom group 2, you will be in Jamboard 2, and at the top of your screen on the left, it will give you a number. But again, we will make sure that you have what you need. If you are watching the recording, you can access the Jamboard in the PDF of the slides in the description.
This meeting is being recorded.
Awesome. Okay, so I'm curious to hear how that went. And so this is, I like this like 3, 2, 1 idea. And maybe you do this with your students. You can think of like, what 3 things do I want? What 2 things? What 1? And then you can fill in the blank. We don't actually need to do 3 ideas that surfaced in 2 ways, but just this idea of 3, 2, 1, maybe it's an exit ticket that you give students at some point. So let's just share like what were some ideas that surfaced in your group, or ways that you could adapt this activity for your students. We don't all have the same context, or a question that you have. So I invite you to unmute. You can also put things in the chat, but I do invite you to unmute and share something from your time with your group.
It was very good having more than just my own set of eyes, as I definitely made mistakes. So having people question, well, why did you put it here? Oh, good point. That is the math property that would make it true. Or that doesn't make it false.
Did anybody else notice that it was nice to work in a group on this? I definitely didn't see some things, and I enjoyed listening to your conversations. And one of the beginning ones that we did, I obviously missed that it was only sometimes true, not always true. Awesome. And Patsy adds like how the group responds to an error sets the tone for all the group work. So that's awesome. You had a gracious group, but I agree. Like if you do have students work together, you might want to have norms around group work and how to handle errors if you don't already, but you may already be doing that. So, because that definitely can help students take risks if they are met with grace. Rebecca, you had your hand up.
I was just going to add on to what Patsy said in our group. We were just noticing that after that first person made a mistake and then recovered, then it made everyone like more willing to investigate and question things. So like, oh, like now it's no big deal because we recovered. And we were just talking about how that would affect be important in the classroom. Like we just almost have a plant of making a mistake and recovering, and then everyone else is less worried about making that mistake.
Yeah. No, that's so true. And I mean, I was there at the beginning when you guys were talking, and I didn't put this in the chat, but I wanted to. You all had great follow-up questions for each other, and you were just talking, and that was really fun to see. So again, how you're responding to errors can help make that possible. And yes, Justine, thank you so much for being here. Christy writes, being reminded that using 1, 0, and -1 for the variable is the quickest way to determine how true or not true the equation is. Yeah, I was noticing that second group, you really developed a strategy. You were using 1, 0, and -1 to kind of gauge, like, where do we go from here? Do we need to do further investigation, or did that answer our question for us? Awesome. Patsy found the same thing. Yeah. Yeah. And I agree. I was listening to your conversation, Rebecca, in Rebecca's group. But I also missed that using the actual number itself. So, you know, if it was blank -5 equals that same, or 5 minus that same number. So a number -5 equals 5 minus that same number. Realizing, oh, I can also try 5, like it is actually sometimes true because 5 minus 5 equals 5 minus 5, but I missed that one. So yeah, any other thoughts about this activity, ways you could adapt this for your students?
Sure, I got one more.
Yeah, go for
it. It took until the E level for me to realize that this was another way to look at solving multi-step equations, and that always true would be equations with where all real numbers would work, and never true would be equations with no solutions.
Yeah. I love that. Yeah, because you guys saw some on each page going from level A to level E. That's awesome. And Sean, do you teach level E?
I do.
Okay, yeah, nice. Rebecca also adds, love the way it opened the door to such rich conversations. Notice that linear equation was the sometimes. So if you can't do this on the computer, or, I mean, some people in this group, I know it's a small group, but I do think there are a variety of contexts represented here. Some might be doing online teaching. This could be a way you can engage students and give them a way to collaborate using Jamboard. But some, might be in person and not even have access to using computers with your students. Like, how could you adapt this activity? Or maybe you're working with one student, you're at a time, you're not working with a group. Like, how would you adapt it? Well, I will show you a resource where, that you could print out. It is at the in the middle and above levels for CCRS. So, but it is a piece of paper with equations on it. You can cut them up and you can give them a graphic organizer with always, sometimes, never, true, and then they're sorting the pieces of paper in the correct column. And maybe you have graph paper where they can be on the side and actually justifying their reasoning for each one. So there's a way you could do that on paper. And if you, and that's just one example, and if you do end up working with a student at a time, or you are, maybe you're doing this activity with a student because you know that it would help this student and you're not going to do it with everybody. Having like, students can still engage with these on their own. You can be another person, a volunteer can be another person, another set of eyes to like ask follow-up questions. You could have, if you are working, in a one-room schoolhouse, you could have a prompt where you don't have like, several statements where it's overwhelming, but maybe you have a couple, and students are making their claims and they're writing it up on their graph paper, and then they're sticking it on the wall. And then as different students come in throughout the week, they're engaging with what's on the wall, and maybe writing questions and whatnot. So, you'd want to set up norms about like how we're going to interact with static paper, and how we're going to be respectful, and how we can ask questions, and how we can make comments, etc. But it could be something that you could interact with over a series of days if it is a fixture in your classroom. So yeah, and I am curious, anybody have questions that you want to bring up? Okay. Sometimes I'll have a higher level student work with a lower level student. They seem to open up more with each other. Yes. And I think knowing your students, and that is another way to pair students, right? A higher level with a lower level. And I think the way we structure the class and the content, and what equations we're choosing, and what statements we're having students interact with, if there are multiple entry points, it can be really a powerful conversation. The student that may be lower level, they can ask questions that maybe the higher level student now takes for granted and hasn't really thought of in that way before. And then the higher level student can maybe mentor that lower level student into some more of the symbolic nature of math and how to write out their thoughts. So yeah, I love that. I do want to share some resources. I'm not going to put them in the chat because I think it's just a lot, but you will get the link to the PDF. And so this page you are going to get. So I'm going to open these up and kind of share some of these so you know what's here. But then when you get the PDF either tomorrow or early next week, then you will have all of these resources here. It's not an exhaustive list, just some things I wanted to share. A&I is adult numeracy instruction, I believe. Correct me if I'm wrong, Rebecca. I don't think it's instruction. And it is, if you've been in Minnesota AVE for a while, you've probably heard of MNI. the Minnesota Numeracy Initiative, where we really talked about foundational principles of teaching math to adults. ANI is the national group, right? And so they kind of revamped the course, and that's why it's called 2.0. And they did a pilot last year, and some teachers from Minnesota were part of that pilot with some updated resources on how to teach math to adults. And so there are things that I want to share with you from that. One of them being this card set, because we did an activity like this, and we only did the activity with these equations. We didn't do it spanning different levels. So we wanted to, meaning the advisory team for math in Minnesota, we wanted to kind of draw out some algebraic thinking across levels, not just once we're ready for these kinds of equations. So that was the webinar today, kind of expanding the idea. But this is a card set that if this is where your students are at, you can use, you can print, cut it up, and students can then sort. So that is in the slides. There's also a resource, when are the equations true, where there is a problem, and then there is a student work Amy, a student work Ben, their reasoning, and then asking like, are they correct? If not, where have they gone wrong? What's your answer to the question? And then a second equation, and then Amy's work, Ben's work, what's your answer to the question? And so students are able to kind of interact with other reasoning, and this is another actual visual representation of what I was talking about. Like in a one-room schoolhouse, there could be work provided, whether it's you providing it or other students, and then a student is working with this one-on-one and kind of analyzing someone else's response and adding their own. So they talk about Amy and Ben, which is important because another link here is, as a teacher, this is a teacher resource, what are some common issues that students might make when they're analyzing that work of Amy and Ben? So maybe they're assuming that subtraction is commutative. Maybe they're only considering positive numbers. Maybe they're failing to explain why Amy and Ben are incorrect for question 1, etc. And then on this side, for each of those common issues that students might encounter, there are some prompts that you can then ask to students to not just give them the answer, but to further their own thinking. So this is a resource that, again, if your students are at that level of that card set, you can use, and if they're at the level of these equations and looking at the reasoning, again, you can use, and then there are some prompts for moving along their thinking. This is another resource. Elizabeth, I'm so glad you think that's helpful. Another resource that I thought was really cool is how they grouped the domains and different levels and what's happening in each one, how they grouped it in a very concise way to look at coherence across levels. And so in number and operations, like what's happening at level A, then B, C, D, E. In algebraic thinking, what's happening, right? And you even see like you're working with unknown values and even variables at level A, right? And I think for myself too, it's easy to forget that, like algebra is right away. Level A is kindergarten and first grade standards. Geometry and measurement, and then data, statistics, and probability. I like it just kind of looking at the range and the progression of different ideas from each level. And I mean, we focus on algebraic thinking today, but I wanted to give you this for the other areas as well. And then the last set of resources here is just like, well, what if we did this with geometry? And so here's an example of an activity, and you could use this or you can model this with other content that you have and just kind of plug stuff in. But like all summer, no, when you're talking about statements regarding shapes, right? All rectangles are squares, no rectangles are squares, some rectangles are squares, reason, right? And so talking about some engaging with definitions and properties of shapes. And then this sketching resource is very similar, but where maybe you are describing a shape and you're sketching it. And I have to add one more link in here about some descriptions that you can use. So I have some pre-made descriptions. I forgot that part of this. Pre-made descriptions, student could use those descriptions. Someone else could be drawing it and then being like, well, what is the mathematical name of that? And then there's some other explaining and reasoning and drawing and cutting out and sticking certain things below to explain, like, how do I know that this is describing a trapezoid, and what are the fewest clues that I need in order to really define a trapezoid? And so I need to actually give you the prompts for that. But it's, again, another way of thinking like all, some, no, within certain parameters for shapes. So that will also be on this slide with the resource that I forgot to link. It will all be here that you can access then in the follow-up email when that is sent. And just a couple notes. I know we have 2 minutes left here. Couple notes, some upcoming PD. January 26th is 26th and 27th is language and literacy. It is in person. You can register through the Atlas website, and we are actually going to drop a link to the Connect newsletter because if you are signed up for that, then you will get notifications of all these events I'm going to show you. When the registration is open, you will get those notifications. So there will be a numeracy and literacy session there that Christine Kelly and I are going to be doing, and we're going to really be taking time to identify specific numeracy supports and specific literacy supports for an existing lesson. And so how do we build math into other subjects, and how does that actually serve the lesson, not just feel like an add-on? So we're going to give an example of that. So if you're interested, you can sign up there on the website. March 14th, Pi Day, we have another math content webinar, and it will definitely involve Pi. And Andy Albee is going to be leading that webinar. And then we have 2 things in April coming up. One is MCTM, the conference in Duluth, the Minnesota Council of Teachers of Mathematics. That is a couple day conference with a pre-conference in there, but Atlas can provide scholarships to help with some of that cost. And so just stay tuned in the Connect newsletter. You will get information as we share that. It is still months away, but you can save the date. And then on the 28th, we will have statewide virtual conference, and there will be more numeracy PD there. So I want to respect your time. You can leave. If you're willing to share something that resonated with you today or something you're puzzling over, I'd love to hear that in the chat. But if you have to sign off, I totally understand. You will be getting a follow-up email with an evaluation that you can fill out, and it is also in the chat. So thank you so much for being here. And yeah, I'll see you at a future event.